So today we're going to begin Pythagoras' theorem, and this lesson is going to be an introduction and also moving on to calculating the hypotenuse, and you're going to learn what the hypotenuse is later on in the slides. So first, before we get started, we need to know what square numbers are and how to square numbers and also finding square roots in order to use Pythagoras' theorem. So here I've got 9 dots in total, representing the number 9. And they've been displayed in a square form, meaning that 9 is a squared number. And you can see that I could calculate 9 by doing 3 columns times by 3, so 3 times 3 equals 9. So we call 9 a square number because we can essentially set it out as a square. That's where the name comes from. And 3 squared, and this little 2 up here means squared. That means 3 times 3 whenever you see that equals 9. So we've got 3 rows times by 3 columns, giving us 9 in total. That's where we get the number 9 from. And if you've ever been asked to square a number, that means times it by itself, multiply it by itself. For example, 5 squared means 5 times 5 is 25. 4 squared, 4 times 4 equals 16. And if we are wanting to work backwards, okay, so most things in maths we've got reverse. Therefore, we say that the square root of 9 is 3. So 3 squared equals 9, but the square root of 9 equals 3. And we represent the square root symbol just like this. So you've maybe seen this before. Write the square root, and what you're trying to find the square root of goes underneath, equals 3. So we'd be thinking, what do we times by itself to get 9? Well, 3 times 3 equals 9. And to do Pythagoras' theorem as well, it is really important that you have access to a scientific calculator. If you don't have a physical calculator, there's going to be a few options for you. So you could either Google scientific calculator, and you should get this, and your little square root symbol is right here. So if you're wanting to find the square root of 9, you'd click that, then click 9 equals, and then you'd get the answer of 3. Or if you've got an iPhone, if you turn it to landscape, your calculator turns to landscape, you'll get a scientific calculator, and this is a square root symbol that you're after. Or if you've got a physical scientific calculator, this is the Casio one, this is your square root sign that you'd be looking for. So you'd click that, click what number you're trying to find the square root of, and then hit equals. And then if you're not happy with any of those, another option would be to download the app, and if you go into your app store and type in NCalcFX, that brings up a really good virtual copy of a scientific calculator, and it pretty much just displays what a physical calculator would look like, but just on your phone in app form. So that's a really good one as well. Either one of those, any of those, that will work really well for doing these questions. Okay, so a little background of what Pythagoras' theorem is and how it works. So here, Pythagoras' theorem only works on a right angle triangle. So here we've got a triangle, and we know it's right angled from this little square in the corner, because this side here, this angle here, will be 90 degrees, and that's what that square represents. So Pythagoras' theorem only works on right angle triangles. And it states that the square formed on the hypotenuse of a right angle triangle, and by square formed I mean if this side here, and this is what we call the hypotenuse, it is the longest side, if I form a square there, so this is 5 centimetres, and I'm going to form a square, so 5 times 5 will give me an area of 25 squared centimetres. Also, just to add, you don't need to copy any of this down right now. I'm just going through the background of the theorem. So here we've got 25 square centimetres. So Pythagoras' theorem states that the square formed on the hypotenuse of the right angle triangle has the same area as the area of the squares formed on the other two sides. So here I've formed a square, and if I form a square on the other two sides, so 3 times 3, that would give me an area of 9 square centimetres. 4 times 4, an area of 16 squared centimetres, And the theorem states that if I add these two areas together, that will equal the area of this bigger square, because we can see that 16 add 9 will give us 25 squared centimetres. And that is the basis of the theorem and where it comes from. Here is a really good video that I found on YouTube just of representing that area between the two smaller squares and sharing it into that larger area. It's just a really good representation of Pythagoras. But to go through problems and questions, we're going to need a theorem that we can work with and a formula. So here we've got a right angle triangle, and we're going to label the sides A, and if I was to form a square on that side, the area would be A squared. This side we're going to call B, and that area would be B squared. And then this hypotenuse, which is opposite the right angle, which is the longest side, we're going to call side C, forming a square there. And we said that if we add these two together, that will give us this area of this larger square. So the area there we can write as A squared plus B squared. Therefore, the Pythagoras' theorem, the formula that we're going to be working with, is C squared equals A squared plus B squared, which is that bigger side, C squared, equals those two smaller squares added together. And just a little note that the longest side, C, that's what we call the hypotenuse. So this longest side opposite the right angle, if you ever hear the word hypotenuse, that's what we mean. Okay, let's go through some of these examples, and we're going to be using this formula, C squared equals A squared plus B squared. So first one, here we have our right angle triangle, and we know this because it has a little square in the corner representing that is a right angle, and we know that Pythagoras only works when we're dealing with right angle triangles. And we're being asked to calculate this length x using the fact we know those other two sides. So find x in this triangle. We're going to start by using our Pythagoras' theorem formula. So we've got C squared equals A squared plus B squared. So we're going to use that formula, and we're going to substitute into that formula. So our C is our longest side, so I've replaced the C with x because that's what we have in the question. I've replaced the side, I'm going to call this side A and this side B, although it doesn't matter if you call this A and this one B, as long as you have side C being the longest side. So I've replaced side A with 6 and side B with 8. So I've swapped out the A for 6, the B for 8. We're then going to go ahead and find the squares of these numbers. So x squared equals 6 squared is 36, meaning 6 times 6 is 36. 8 squared, meaning 8 times 8 is 64. So I've just calculated those. Then we're going to go ahead and add those numbers together. So 36 add 64 is 100. So x squared equals 100. We're just trying to find out what x is. So if this is x squared, we learned previously that the opposite of squaring a number is finding the square root. So we're going to find the square root of 100, giving us just x on its own equals the square root of 100. So we're almost at our answer. Either thinking about what number times is by itself to give you 100, or you can use whatever calculator preference you chose, using that square root button, typing in 100, and you will get 10, and we're using centimetres. So that is your answer. So when you're doing these questions, it's really important that you have all these lines of working. It might be that you get a bit quicker at it, and I would allow you to miss out this second line. So if you type in your calculator 6 squared, add 8 squared, and you would get 100 straight out, that's fine. So minimum 4 to 5 lines of working when you're doing these questions. So using this example to help you, you don't need to copy these examples down as long as you're following the your turn questions, closely referring back to the examples that I've been through. So pause the video here, using this example to help you find the side x to this triangle. Okay, hopefully you've unpaused and managed to give that a go. Let's go through the answer. So we're going to be using our formula c squared equals a squared plus b squared. We're going to use that Pythagoras' theorem formula and we're going to substitute in. So swapped out the c for x, swapped out the a for 8 and swapped out b for 9. That's where we've got this first line from. We're then going to find the squares of these numbers. So 8 squared is 64, so 8 times 8 is 64, 9 squared is 81. We're then going to add them together to get 144, so that's x squared equals 144, but we just want to find x, so we need to square root 144 to get the answer of 12. 12 centimetres, don't forget your units, so well done if you got that. Okay, second example. This time we're still going to be using the same formula. I'm just showing you that it doesn't matter which way round your triangle is, as long as you've got that little box there representing your right angle triangle. The side directly opposite from that is your longest side, being your hypotenuse. So we're going to use the same formula, just on a triangle just being flipped around a little bit. So this side x is going to be our side c. So find side x in the triangle. So we're going to be using this formula and we're going to substitute into our Pythagoras' theorem. So I've swapped out c for x because that's what we're trying to calculate. I've swapped out a for 8, so I've called this side a. I've swapped out b for 15, calling this side b. We're then going to find the squares of those numbers. So 8 times 8 is 64, 15 times 15 is 225. Add those squares together, so I'd get 289. And then finding the square root, because x squared equals 289, but we just want to find x, to give me 17 centimetres. Okay, so again, using this example to help you remember all your steps, can you please pause the video here and calculate side x on this triangle? Okay, hopefully you managed that and you've unpaused, and let's go through the answer. Okay, so we're going to be using our Pythagoras' theorem. I'm going to first start by substituting into the formula. So I've replaced c with x, replaced a with 7, replaced b with 24. Then I'm going to use the calculator to work out our squares. Well, 7 times 7 is 49. 24 times 24 gives you 576. We're then going to add those squares together. Find the square root of 625 because that is x squared. We're just wanting x, so x equals the square root of 625. And you should have got 25 centimetres, so really well done if you got that. Okay, so moving on to our third and final example. In these examples, we have just been working with whole numbers, but we can absolutely use Pythagoras' theorem if we have decimals. So you will definitely need to be using your calculator for these questions. So we're still trying to find the length of the longest side, so find the side x of this triangle. We're going to be using our Pythagoras' theorem formula. And we're going to be substituting in what information we have. So side C is our x, side A is 8.9, so I've swapped out the A for 8.9 and then swapped out the B for 22.7. We're then going to use the calculator, so either using the squared button, so 8.9 squared, or 8.9 times 8.9 gives you 79.21. Then 22.7 squared is 515.29. Or doing 22.7 times 22.7. Then going to add those two numbers together to get 594.5. So x squared equals that. We're just wanting x, so we need to square root 594.9 using that square root button. And once you do that, you will get a big long decimal number, most likely, if you're squaring, well, definitely if you're squaring a decimal number. But we want to give our answers correct to 2 decimal places, so really be careful with your rounding here. Make sure you're rounding it correct to 2 decimal places, and for this question we'll get 24.38 centimetres. So again, just reiterating the fact that we can use this formula with decimals, and just be really careful with your calculator input, making sure at the very end, you're rounding to 2 decimal places accurately as well. So using this example again to help you, pause the video here and calculate side x to this triangle. Okay, so let's go over the answer. Using our Pythagoras' theorem, c squared equals a squared plus b squared, we are going to substitute into our formula. So our side C is x, side A is 6.8, and then side B is 8.3, giving us our first line. We're then going to find the squares of those numbers, so 6.8 times 6.8 is 46.24, 8.3 times 8.3 is 68.89. We're then going to add them two together. So x squared equals 115.13. You want to square root that answer, you'll get a big long decimal number. You want to make sure you're rounding your answer correct to 2 decimal places, writing that in your final answer as well that you have rounded, so you can put that in brackets. And you should have got 10.73. So really well done if you got that correct.